Hello, Assalamu alaikum everyone. This is Mohammad Zakaria Khan, and I hope you all are doing well. So, before we start our presentation, I would like to introduce you all with my group mates first. I myself, Mohammad Zakaria Khan, and my group mates are Zuma Mohammed Shoraf, then Ryan Ruku, and lastly Rezanul Alam. So, this is all about us. Now, let's talk about neuromorphic computing. Firstly, what is neuromorphic computing? Neuromorphic computing is a method of computer engineering in which elements of a computer are modeled after systems in the human brain and nervous system. And neuromorphic computing also uses features of biological neural network like analog or digital copies on electronic circuits. Now, what are the main goals of neuromorphic computing? The first goal of neuromorphic computing is creating a new path for neuroscience to understand the dynamic processes of learning. Then, secondly, using the newly learned data for development in the brain and applying brain inspiration to generic cognitive computing. Thirdly, allowing computers to work fast and on less energy with the help of algorithm and data. And lastly, producing computers that can work as efficiently as human brain without taking up extra room for the placement of software. So now then we all know what is neuromorphic computing is really about and what are the main goals of neuromorphic computing. Now I would like to invite my group mates Jubair Mahmood Shorab to give you further details on neuromorphic computing. So thank you everyone.
Hello, I'm Zubair Mahmood and I'll be discussing how neuromorphic computing works. So, neuromorphic computing achieves brain like functions and efficiency by building artificial human brain like neural systems, which implements neurons and synapses which transfer electrical signals using analog circuitry. Now, we all know the goal of neuromorphic computing is to achieve human brain like functions. The human brain can think fast, can work fast. This is the same goal of neuromorphic computing. As a result, the processes which takes place within neuromorphic computing is like the human brain. We all know the human brain is interconnected. It receives signals in the form of neurons, and similarly in neuromorphic computing, there are neurons and synapses, meaning there are connections which allows electrical signals to be passed using analog circuitry, and as a result, the working of neuromorphic computing is very fast, and it is human brain like. Now, spiking neural network, or SNN, it is a feature of human brain, and this measures the spikes in the neural networks, means the speed or the amount of information that is being passed at one time. This kind of feature is also implemented in neuromorphic computers, which allows the computers to measure and control the amount of analog electrical signals being passed at a time. Neuromorphic systems also introduce a new chip architecture. Now, what are new chip architectures? This kind of architecture collocates memory and processing together on each individual neuron instead of having separate designated areas for each. As a result, uh, memory and processing takes place simultaneously on each individual neurons instead of taking up a lot of time for processes to take place in different neurons. So this further proves that neuromorphic computing is trying to achieve brain-like functions and faster computing. Now, a traditional computer uses von Neumann architecture. We have already learned about von Neumann architecture in class, and von Neumann architecture causes a von Neumann bottleneck, which kind of slows down the process when compared to neuromorphic computers. Neuromorphic computers, as I have already mentioned, uses a new chip architecture, which collocates memory and processing together on each individual neuron, and this results in faster task completion and results in faster programming, faster computing as a result. So this is how neuromorphic computing works. Basically, there are synapses and neurons, and they are interconnected, and there is a new chip architecture which allows faster computing and faster programming. Now, what are the features of neuromorphic computing? Now, neuromorphic computing, as I have already mentioned, is very fast, wants to achieve brain-like functions. So, as a result, it achieves fast computation and low power consumption. Because there is so much fast competition, it does not require a lot of time or a lot of power uh, to achieve this to complete tasks, and as a result there is low power consumption. Now it is massively parallel. As I have already mentioned, processes and tasks take place simultaneously on each individual neuron at a time. So as a result, neuromorphic computing is massively parallel and can handle many processors at once. Now neuromorphic computing is event driven. Now what does that mean? This means that they can respond to various events based on environmental conditions. Now this is similar to the human brain. This human brain reacts to environmental conditions around us. Similarly, neuromorphic computing does so, and by using only those parts of the computer which are needed at the time. As a result, low power is consumed, and only the parts which are needed to work based on the environmental conditions are worked. Now, neuromorphic computing is highly adaptable, and it is also high in plasticity. Neuromorphic computing can work with very high-end programs because, as I have already mentioned, it is very fast. It consumes low power. So different programs can be worked using neuromorphic computing because of its high adaptability and high plasticity. Now, neuromorphic computing is strong and fault tolerant. Now, neuromorphic computing, as I have already mentioned, is very fast, uses a new chip architecture. So, as a result, when processes and tasks are taking place on an individual neuron, even if other neurons fail, the processes which have already taken place on other neurons can still be executed and can still produce results. So these are the features of neuromorphic computing, and we can see that it is the future, and it is a very good alternative to the traditional computers that we have right now. Now my group mate Ryan Ruko will discuss about what are the methods used for researching neuromorphic computing. Thank you.
Hello everyone, my name is Ryan Rocco and I will be discussing the methods used for researching neuromorphic computing and the results we get through the computing. So, the neuromorphic computing uses Hopfield natural neural algorithm and training, which was proposed by J. Hopfield in 1982, and it is a completely connected network where all the neurons are the same structures and they are equally connected. So each neuron receives information and they pass through the information to each and everyone. That's why the information passes through faster and we can process everything faster. And here the signal can transfer information between both positive and negative directions, whichever we need to compute any problem, and then it enables the output of neurons to be controlled by other neurons. This also has supervised and unsupervised learning. Supervised learning has the data of training samples which are loaded into the network input end. Meanwhile, the corresponding expected output is compared with the network results to achieve difference value. So to adjust the connection strength on the weights and converge to a certain weight after repeating training. If the sample situation is changed, then weights can be modified to adapt to the new environment after training. Neural network models using supervised learning include backpropagation networks, perceptions, etc. In unsupervised learning, the network is directly placed into the environment without giving the standard samples. The learning and the working combined as a stage. At this point, the learning rule transformation is based on the evolved equation of connection weight. The classic example of unsupervised learning is the Heb learning rule. Moving on to the list, next one is results of the research. Neuromorphic computers are presently not being used in real life applications, and there are still many challenges that restrict the rapid growth in algorithmic and application development. There is still to come a machine learning algorithm or application combination for which neuromorphic computing significantly outperforms deep learning methods when it comes to accuracy. There is huge algorithmic opportunity for neuromorphic computers. Although neuromorphic hardware is available in research community and there have been a wide variety of algorithms proposed, the applications have been primarily targeted towards benchmark datasets and demonstrations. The computers are not currently being used in real world applications, and there are still a variety of challenges in front which restrict them to focus on the results. There has been a focus on backpropagation based training approaches because of their state of art performance in deep learning. By limiting focus to those algorithms, however, we may also be limiting ourselves to achieving results that are only comparable with deep learning approaches. At the same time, the approaches have also been iterated on for decades. They similarly have not been achieved state of art results. This was my discussion. I will request my groupmate Bezon Alum to discuss the rest. Thank you.
Hello everyone, I am Rizwanul Alam and I will be concluding this presentation on neuromorphic computing. In our rapidly evolving AI-based world, much of the AI research and development focuses on improving and deploying deep neural networks and AI accelerators. On the other hand, traditional von Neumann systems have a design limit and the exponential growth of data size and processing capacity needs more innovative and powerful solutions. Neuromorphic computing is a well-developed and well-known area among neuroscientists and neurocomputing researchers. It is a trend of most recent and unique technologies that contribute to discovering and simulating the human brain's learning mechanisms. My group member Zakaria, Zubair, and Ruku have already explained what neuromorphic computing is, how it works, and how it is researched. So, in summary, neuromorphic computing will open up previously unexplored AI capabilities and create a revolutionary precedent in the next few years. Although neuromorphic computing has received much attention in recent years, it is still in its infancy. This concept will gain more traction and respect in the long run since it will welcome the third wave of AI. The majority of neuromorphic computing research is currently focused on how it can be employed in devices. So, hopefully, this report has shed some light on the complexities of this challenging computer field, and that brings us to an end. I would like to thank you all for your attention.